Welcome to this video, guys. So in this video I want to present my setup. It's a Ryzen 5950X with Asus X570 Pro and 128 gigs of RAM. So basically this is maximum of the IM4 platform, and surprise surprise, we have running the full Deepseek model. Basically there is one model which is being a little bit tweaked from the full model, but it will hold like 130 gigabytes, and after that this model basically it can run on my Ubuntu system with a little bit of swap. So as you can see, the model is running. So basically 124 gigs and just 14 gigabytes of swap. It uses part from the GPU, it uses part from the CPU, and basically it's using both, and is writing in the moment the Python game. I told him write me a snake game in Python. So let him finish and we're gonna continue. Okay, let's go to our forum. On our part of the forum, which I explained Llama and Llama CPP installation and configuration using the Rocm. It's a AMD alternative to CUDA. And here my GPU is Radeon 6950 XT. And here I explained how we can install Llama CPP, which is basically another way of running IE models. Basically, first you need to install Rocm and AMD proprietary driver. Of course, Rocm works with open source driver, but we're still gonna follow official AMD recommendations and install the last version of their libraries and everything. So first we're gonna install this. After that, of course, this is for Ubuntu 22.04. Probably will work for Debian, but I didn't test yet. But some other tests on other operating systems like Linux is coming, so I will see how we work on Debian also, which is not systemd distribution, one of my favorites. And of course, after we install all the dependencies, now we are going to export, because this GPU is not officially supported by AMD for running the last version of Rocm, but you can still make it work with this little hack. So basically we are copying paste these commands, and it will force the Radeon GPU to use Rocm. Of course, the official W6800, which is professional version of this card, it's officially supported. But after we force this, it will work. After that, we need to fix some basically environment variables. So just copy entire thing, paste it in terminal, and after everything is added, we can check our configuration, and it should it should prompt. First, we can try this for Rocm info, and after that, this will show the current version of hype config. Let's after that, after we see that everything is fine, 1 second, I can show basically on working system how everything is working. Okay guys, so a little bit of pause, but let's continue. I had to connect to my from this Windows system. I had to connect to my Ubuntu. So here is the SSH, and let's see. Basically, to test the commands, I need to just one second, where we were. Here. So if you want to check the everything is okay and Rocm is basically working on your system, you can copy this and it will print the name of your GPU, and actually it's showing AMD graphics core next GFX 1030. So if this is printing, and actually this command also, yep, it's showing version 634113 blah blah. So if these commands are working, congratulations, you have installed everything. So after you follow this, and basically you're ready to build the Llama CPP. So you're cloning this GitHub, also going to this directory, and before you build, basically after you're into this LLM directory, you copy paste this, and after you copy paste, basically you are just here. The CPU is like it's made to use 16 threads. If your CPU is a little bit slower, basically you can change this with 8, doesn't matter. And here is the official GitHub. So here, after you build, basically, let me show you. So cd llama cpp. After that, another tool I forgot to mention. Another tool you can use for monitoring your GPU is Radeon Top. So it's a console monitoring tool. You can see basically it shows VRAM, it shows the graphics pipe, everything. So I will demonstrate after I finish this and run the example that basically the GPU is being used. So we can quit this for now, and let me show you the Llama CPP build bin, and let's see the example. So let's see, run 32. So here is the example how you can run basically how Llama handles the defaults. You can run this like how many threads. Prio is basically your CPU priority. I found out that if you push Prio more than 0, sometimes it's crash. So not gonna make huge difference in performance, basically almost 0 difference. So basically leave it as 0 it will make a system work more stable. That's from my experience. NGPU layers is basically how many layers of GPU you're gonna use just to run this. So let me give you an example. Let's say you have queen coder 32 billion parameter, which is around 30 gigabytes, something like this. So you open Radeon top and you start to experiment with NGPU layers. Basically, NGPU layers is how many layers of this computation you're offloading to the GPU memory. But still, from my experience, I understand that it's not like percentage. It's more like, for example, if I have 32 billion parameter and 32 gigabytes model and 16 gigabyte GPU, basically with this 25, it's almost full my GPU. So every different model you are downloading, for example, you need to experiment a little bit with this value to see how much RAM basically is loading your GPU. So let me run the one example, and I'm gonna show you in practice how it works. So okay, I open another terminal and I run Radeon top, which is this GPU utility. You can install apt-get install Radeon top on Ubuntu. It will install. And for example, let's build a new test systems that will use our GPU fully. So let's say you wanna run Deepseek, but just a smaller model that can fit in our GPU. So I can show you how basically Rocm on AMD is being used. So let's say CP run 32. Okay, so we're gonna change to run 40. Let's say Deepseek, like something like this. So nano run 40 like this, and now here you need to change the path to your model. So for example, let me, for example, that's my model where I download it. So okay, so here is the 40 billion parameter Deepseek R1. We change the full part, and here we can just put this value 60, because I test basically from 60 to 100. There is not much difference, so basically it will offload most of the model to the GPU. So let's quit and run the model. 40 like this. So now you see the model is loading. Here is showing the Deepseek R1, Queen, blah blah blah, and after that you can see Rocm. 1 second. You can see Rocm buffer size. So how much of this model is being allocated to Rocm, our GPU, and from the right side you can see how much VRAM, basically, because the system is using a little bit of VRAM. Probably you have some open tabs and stuff like this, and it's at 40 gigabytes from the model, and that's how is how you can see basically the model is loaded and it's on the GPU memory. here. So and you can see the system started. So we can ask hello, and you can see how much is faster. Maybe I should put it like this, and just to be able to see better, like this. Okay. So hello. Tell me a story in 100 words. And it's working. You can see the graphics pipeline, the shader interpreter, the memory clock and GPU clock, everything shader clocks, and it's fast. So as long we can upload the entire model into the GPU, basically we are fine. It will use our GPU at maximum possible speed.